How do you determine which gender likes math class more? How do you, how do you determine which gender likes math class more? If a class of students were asked about their view on math class, is there any way to determine if one gender truly likes math more than the other? In this lesson, you will learn how to use two-way frequency tables by determining if the data is a frequency count or a relative frequency. A two-way frequency table is a chart in which we compare two variables at once. A two-way frequency table is constructed by placing the one particular variable of the problem on the top row and the other variable on the left side. In this case, we would be comparing males and females to liking or disliking math. Remember that the placement of the variables is interchangeable as long as both are listed and the data is placed in the correct boxes, and to always include an extra row and column for the totals. After the table is constructed, the data can be entered into the appropriate places. Don't forget to add the columns and rows. I typically add down the columns and then across for the rows. Be sure to check that the final box in the far right bottom equals the totals from the rows and the totals from the columns. Remember that there are two types of data within a frequency table: categorical data and numerical data. Categorical data is data that isn't represented numerically. Examples include eye color, favorite car type, and many others. Numerical data is our frequency counts. It is something countable, like how many people are a certain height, or a count of people who are 150 pounds. The data in a two-way frequency table is not quantitative. It is just a count that represents categorical data. We have to be careful that this is not confused. The numerical data within the table is just a count of how many times each category happened. A two-way frequency table is all about the amount of times something happens or is observed. This is called a frequency count. In this table, males who like math has a frequency count of 13. This means that out of a class total of 31 students, 13 males said that they enjoy math. The 13 only represents that particular condition, males who like math. Data entered in the total row and the total column are called marginal frequencies. Looking at our notebook paper, we can see the margin. This is a good way to remember marginal frequencies. The margins are the outside parts of the paper, as the marginal frequencies are the total rows and columns. Data entered into the body of the table are called joint frequencies. A great way to remember this is that our own bodies have joints within them, like elbow or knee joints. They are contained within the body just as these frequencies are contained within the table. These frequency counts can be used to calculate probabilities. For example, if we only looked at the amount of males that like math, we can say that out of 15 males in the class, 13 like math. So, 13/15 is 86.6% repeating. This probability compares just one category to its total. This type of calculation is known as a relative frequency. If we know the condition of being male, it leads us to understand that 13 out of 15 males like math. This is a conditional probability, meaning that it is conditional on knowing part of the data, in this case, males in class. By calculating the conditional probabilities, you could determine which gender likes math more. We can also rewrite the data in a two-way frequency table as a relative probability instead of just a count. These probabilities are calculated by comparing each joint to the overall total. The calculations are done by taking each individual box and dividing it by the total of students. For example, if you took the condition of how many males in the entire class like math, you would see that out of 31 students, 13 males like math. Now simply divide these two pieces of data and leave your answer as a decimal. Do this same calculation for the rest of the data to create a relative frequency chart. These relative frequencies can then be used to create a segmented or stacked bar chart. In this graph, each bar is a whole and is divided proportionally based on the conditional distributions for each variable. For example, the proportion of females that like math is 0.355. We divide that by the total, 0.516, to give us 68.7%. The proportion of males that like math is 0.419 divided by 0.484 to give us 86.6%. The proportion of females that dislike math then is 0.161 divided by 0.516 to give us the 31.3% left. The proportion of males that dislike math is 0.065 divided by 0.484 to give us the final 13.4%. A segmented or stacked bar chart is a great way to show and compare each variable. It makes it much easier to see which gender likes math more. The proportion of males that likes math is higher than the proportion of females who like math. Remember that a two-way frequency table has a lot of uses. We have frequency counts, which is all the numerical data in the table that is just a count of how many times each category occurred. There are marginal frequencies, which are just the frequencies on the outside edges of the table. We also have joint frequencies. These are all the counts that are inside the body of the table. And finally, we have relative probabilities, in which we must calculate a category's likeliness to occur. In this lesson, you learned how to use two-way frequency tables by determining if the data is a frequency count or a relative frequency.